Hi viewers, today let us get into the topic of substation automation system using SCADA. In the previous video we have seen about the introduction to SCADA systems. Now let us get into the application of substation automation system using SCADA. And myself Indumati, Assistant Professor Mechatronics Engineering, K.S.Rangasamy College of Technology, here to present you the topic under the subject of Industrial Automation Protocols. First of all, what do you mean by substation automation system? So, in substation automation systems, SCADA performs the operations like bus voltage control, bus load balancing, circulating current control, overload control, transformer fault protection, bus fault protection in the substation equipments. So, if the SCADA systems continuously monitors the various equipments in substation, and accordingly it sends control signals to remote control equipments. Also, it collects the historical data of the substation and generates the alarms in the event of electrical accidents or faults. So, SCADA performs automatic monitoring, protection, controlling of various equipment in all distribution systems among the substation with the use of intelligent electronic devices, that may be IEDs or PLCs or RTUs, remote terminal units. It restores the power service during fault condition and also it maintains the desired operating conditions. SCADA improves the reliability of supply, reducing duration of outages, and also gives the cost effective of the operation among the distribution system. It can be categorized as substation control, feeder control, end user load control. And this is the substation control. Here we are having transformers, circuit breakers, switches, etc. And these are all the substation equipment which are all interfaced to the RTU or IED, that is remote terminal unit, and integrated electronic devices. So, each and every data acquisition from the transformer, circuit breakers, switches are connected to the data, that is whether it is digital data or analog data, that and all will be connected to the data acquisition system using these RTUs and IEDs. So, these acquisition of the substation data are connected to the modem, and this communication modem using radio, PTC, optical fiber, WAN or IoT device, nowadays also it is possible. So through this modem it is connected to the various supervisory control modems, and these supervisory control modems are again connected to the RTU interfaces and gateways. So this is finally connected to the main supervisory operating station system, that is main SCADA system, that is database, plotter, operating station, monitoring of the computer. Everything can be possible using this substation control using SCADA. So the above figure shows the typical SCADA based substation control. The central control or master unit receives and logs the information. Before that we collected the data, IO data from the RTUs, and then it is master unit receives and logs the information. Logging means displaying or recording of the information, displays on HMI and generate the control actions based on received data. So the data historian, workstations, MPUs and communication servers are connected by LAN at the control center, and then we are using a wide area network connection with the standard protocol communication is used to transfer the information between field sites and central controller. Thus, by implementing SCADA for substation control, eventually improves the reliability of the network and minimizes the time with high-speed transfer of measurement and control systems. So, next categorization is feeder control. Thus, by implementing SCADA for this automation includes feeder voltage or VAR control and feeder automatic switching. Feeder voltage performs voltage regulation and capacitor placement operations, while feeder switching deals with the remote switching of various feeders and the detection of faults identifying fault location, isolating operation, and restoration of services. So these things can be possible using the SCADA architecture. Continuously we checks the faults and their location by using various wireless fault detector units deployed at various feeding stations. In addition, it facilitates the remote circuit switching and historical data collection of feeder parameters and their status. So this is the feeder control here we are using. So this is the here we are using remote control load brake switch, remote controlled rate closers, and fault passage indicators, the RTU, ring main units. So which are all these are all the feeder equipment which is connected to the Ethernet, GSM, GPRS or PSTN, so that the things are communicated through the remote control system through the SCADA buses. And the next topic is the different feeders are automated with modular and integrated devices in order to decrease the number and duration of outages. So underground and overhead fault detection devices provide accurate information about transient and permanent faults so that the remote site preventive and corrective measures can be performed in order to reduce the fault repeatability. So ring main units and remote control terminals of underground and overhead network are responsible for maintenance and operational duties such as remote load switching, capacitor, bank insertion, and voltage regulation. The entire network is connected with a communication medium in order to facilitate remote energy management at the central monitoring station. So the next one is the end user load control automation by SCADA. So the end user, this type of automation at the end user side implements function like remote load control and then automatic meter reading and billing generation, etc. It provides the energy consumption by the large consumers and appropriate pricing on demand or time slots wise. Also, it detects the energy meter tampering and theft and accordingly disconnects the remote service. Once the problem is resolved, it reconnects the service. So here, this is the end user side SCADA application. So here we are having a smart meter. The smart meter this is our consumer side. So consumer side we are connecting all the components equipments through IEDs, integrated electronic devices. These are connected to the remote terminal units and then it is connected to the smart meter, which is substation 1. Then again it is substation N. Number of substation can be connected here, and then so this can be connected to the smart meter with modem to the Ethernet via the Ethernet GSM or GPRS to the main remote control and monitoring of the SCADA. So this is how we are connecting the end user load application to the SCADA. So this figure shows a centralized meter data management system using SCADA. It is an easy and cost-effective solution for automating the energy meter data for billing purpose. In this, smart meters with a communication unit extract the energy consumption information and made it available to a central control room as well as local data energy storage unit. At the central control room, AMR control unit automatically receives, stores and converts all meter data, energy meter data. So modems or communication devices at each meter provide secure two-way communication between those central control and monitoring room and those remote sites. So due to what are the advantages? So we can see the three categorization of automation using SCADA in substation equipments. Now what are the advantages of these implementation in SCADA systems for electrical? Let us see. Due to timely recognition of faults, equipment damage can be avoided easily, and then that is previously we can detect the fault, and continuous monitoring and control of distribution network is performed, saves labor cost by eliminating the manual operation of distribution equipments, and reduce the outage time by a system-wide monitoring and generating alarms to address problems quickly, improves the continuity of service by restoring service after the occurrence of faults, automatically improves the voltage profile by power factor correction and VAR control, facilitates the view of historian data in various ways, that is using alarm logging technique. It records all the historical data of the particular equipment and it reduces the labor cost. So these are all the advantages of substation automation using SCADA. Hope you can understand the things by watching this video. Thanks for watching this video. Keep learning and keep growing. This is signing off, Indumati, Assistant Professor, Mechatronics Engineering, K.S.Rangasamy College of Technology. If you have any doubts, please post it in your comment box. Do subscribe our channel, like, subscribe and comment.